Someone has requested that I do some videos showing how to work out some of the problems that are on the quiz. So that is what I'm doing here. And I'm using one of your quizzes as an example. All right, so this first question number 2 on the quiz, for some of you, if you want to go ahead and write this down. Okay. It says, what concentration of NH3 is needed to produce a pH of 12.4? All right, so concentration of NH3 to produce 12.4. So NH3, and we want a pH of 12.4. All right, so let's start here with the equation. So NH3, we should be able to recognize that as one of the examples that is used a lot of the time for bases. So NH3, so remember that these Bronsted-Lowry bases accept protons. So this is going to take on, when you mix it with water, and I'm going to do the short version of this. I'm not going to show the water. So when you mix this with water, it's going to accept a hydrogen to become NH4 plus, and then what's left over from the water is the OH. All right. Now, this is 12.4 pH. All right, so remember pH, we can get the concentration of hydrogen. But in order to get a concentration of hydroxide, we have to have pOH. And also remember that pH plus pOH is equal to 14. So to get the pOH, I have to subtract 12.4 from 14. And when I do that, I get 1.6. Now, to get the concentration of hydroxide, I need to take 10 to the negative 1.6. All right. So 10 to the negative 1.6. That's going to give us 2.51 times 10 to the negative 2. Okay, so I can fill out since this is a weak base, we have to do an ice chart. And this is what we're looking for, the concentration that is needed to produce this pH. So this is going to be 0 and 0 for the initial. This is going to go down by some factor of H. This is going to go up, X. This is going to go up by X, and this will go up by X. So the equilibrium here is going to be our concentration minus this X, and X. All right. So our equilibrium expression is going to be X squared. Okay, so it's the products, and we have two products here, X and X. X times X is X squared over our reactant. And this is all going to be equal to the Ka. So we need to look up the Ka for this equation. So let's go to our Ka chart. And we're looking for NH3 to NH4. Okay, so here it is right here. So we have NH4 yields hydrogen plus NH3. So it's going to have to be written backwards. So if this is 5.6 times 10 to the negative 10, all right, 5.6 times 10 to the negative 10. To get the KB for this, oh, let me write this here. This is the KA. But we need the KB. So to get the KB for this, I'll go ahead and leave that there. I need to take 1.0 times 10 to the negative 14th divided by this, and that's going to give me the KB that I use right here. Okay. So 1.0 times 10 to the negative 14th divided by 5.6 times 10 to the negative 10. 1.79 times 10 to the negative 5th. We're going to substitute in our value for x there. And that is, let me go back to here. All right, so we got the concentration here of the x because the concentration of hydroxide from the pH is 2.51 times 10 to the negative 2. So we can substitute that in there. Okay, so I forgot that step. We're solving for the question mark. So let's go ahead and write that. 2.51 times 10 to the negative 2 squared over question mark minus 2.51 times 10 to the negative 2 is equal to 1.79 times 10 to the negative 5th. Okay, that's what we're solving. All right, so let's go back here and let's do 2.51 times 10 to the negative second squared over, let's use x as our variable in this expression, minus 2.51 times 10 to the negative 2. All right, that's all equal to 1.79 times 10 to the negative 5. So there's our algebraic expression. We want to solve for x here. So you have to tell the TI inspired to solve for, that's the comma, it's the symbol, solve for x. All right, and when we hit enter, x is 3.52 times 10 to the 1. Okay, 3.52 times 10 to the 1. So 10 to the 1 means move your decimal place one place to the right. So this is going to be 35.2 molarity. So let's see if that's what it gave us the answer in the quiz. Oh, all right. So in order, because some of the variables that Canvas plugs into here, for the pH here, some of them will get you a very, very small number, like times 10 to the negative 7th or 8th or 9th or whatever. And Canvas has a limitation. It cannot calculate anything smaller than 10 to the negative 4th. So in order for you to, and this is an important question for you to know how to solve, in order for you to be able to solve this and enter it into Canvas, then I have special instructions here. So whatever answer that you get, multiply that by 1.0 times 10 to the 7th, just to make it a larger number, because Canvas can deal with really big numbers, just not really small numbers. So if we take this and multiply it by 10 to the 7th, this is what we get here. And so this is just moving this decimal place 7 times. So I know it's weird and funky, but it's a way for you to be able to do this type of question in Canvas until they get that fixed. I have reported this, and I've heard that they are working on that. All right. So I got 35.2. So right here, 35.2 times 10 to the 7th. Okay. All right. For this next question, go ahead and pause and write this down or take a screenshot. All right, it says the student was instructed to prepare a solution of hydroxylamine NH2OH for a lab on titrations with a pH of 9.904. The teacher gave her 6.4 grams of the crystals to use, and she was instructed that she must use all of the chemicals that are given. The Kb for hydroxylamine is 1.07 times 10 to the negative 8. How many milliliters of water must she use to make this mixture that she used all of this crystals, and it came out to be a pH of 9.904? Okay. All right. So a lot going on there. So first of all, let's write down the formula for hydroxylamine. NH2OH, and the pH is 9.904. Okay. And she must use 6.4 grams of crystals. And let's see, did we have other? 1.07 times 10 to the negative 8. Okay, that's the KB. I'm pretty sure they said KB there. Yeah. All right, so let's get our equation. So this is a KB. A KB is given to you. So that means that this is a base. And another clue is if it ends in amine, it's a base. All right, so bases accept hydrogens. So we're going to rewrite this with another hydrogen, and OH is left over. We know this is a weak base, so we're going to have to draw an ice chart. So these questions are kind of done all the same way. You just have different little pieces of information that you're needing to use in order to get this. All right, so just like before, we have a pH, but that tells us the strength of the hydrogen. We need the strength of the OH. So I'm going to take 14 minus 9.904. Okay, and that's going to give me 4.096. Now, since this is the POH, I can get the concentration of OH from that. So 10 to the negative 4.096. Okay, and that's going to give me 8.02 times 10 to the negative 5th. All right. So let's see. We have some concentration here. We don't know what that is. 0, 0. This is going to go down by x. This is going to go up by x. This is going to go up by x because it's 1 to 1. So it's 1x and 1x. So here we have x, here we have x, and here we have question mark minus x. All right, so let's see what other information that we have. It says 6.4 grams. Okay, so we need a concentration. So we know in order to get a concentration, it's moles over liters. So we're trying to solve for this right here. Okay. And we're given grams, which we can convert into moles because we know what chemical it is, and we can use the molar mass of this to calculate moles. All right, so the molar mass, I'm just going to tell you, molar mass of this is 33.04. So if you take 1 nitrogen and add it to 2 hydrogen and add it to 1 oxygen and add it to another hydrogen, you're going to get 33.04 grams per mole. Now, when I say take 1 nitrogen, I mean the molar mass of nitrogen from the periodic table. So that's 14.01. And then 2 times 1.01 for hydrogen, and then 16 for oxygen, and then 1.01 for hydrogen. Add up all of those and you get 33.04. All right, so we're going to have to solve for this question mark here. Okay, we're going to need to get a concentration of there so we know how much volume of water that we add to equal this concentration. Okay, so if I were to rearrange this to get the formula that I need, it's going to be liters is equal to moles over molarity. So we need molarity. We're already going to have the moles because we're going to calculate that in just a minute, but we need the molarity here. Okay, so let's substitute in our value for x. Let's write down the equation first. So this is going to be x squared over question mark minus x is equal to 1.07, which is the kb, times 10 to the negative 8. Now let's substitute in our value. We calculated from the pH for the concentration of the hydroxide. So this is going to be 8.02 times 10 to the negative 5th squared, because it's x times x, over question mark minus 8.02 times 10 to the negative 5th is equal to 1.07 times 10 to the negative 8. Now, in that last question, I showed you how to put this in in the calculator, Inspire calculator, to get your answer. But I neglected to go back and show you how to do it without the TI Inspire, like your normal calculator. So there's really no easy way to do that. So we're going to have to make a shortcut here, or a way to do this that's easy enough and it's not going to take you 30 minutes to calculate it. Because if you have the way this is set up, let's go back and look at the calculator. The way this is set up, in order to get that, you would have to use the quadratic equation. I'm pretty sure. No, that's if you're solving for x. Okay, so you could do this. All right, in order to do this, we're going to have to assume that this x right here is so small that it doesn't affect the significant digits of our concentration. So since this is a weak base, this dissociates to such a small amount, this negative x here, that it doesn't affect the significant digits of the concentration here. So with that assumption, we can go ahead and leave this X off and then calculate this, and it makes it much, much easier. Okay, much, much easier. All right, so in order to put that in the calculator, we're just going to leave this part off right here. So we can go ahead and rearrange this. So here we have X. So to move this X over here, we're going to have to multiply by X. Okay. And then to get rid of this square here, we're going to have to take the square root of this number. So it's going to be 3 3, 2, 1. Okay, we can assume, since this is some concentration minus X, this goes down by X, this is a weak base, so it's going to dissociate to such a small amount that this value of X is not going to affect the significant digits of this number here. So with that assumption, knowing that, we can drop off this X. Okay. All right, so now we're solving for the question mark. So you're going to have to set this up as a proportion. And this is the way that I've seen a lot of students work this out. Instead of rearrange it to solve for X is equal to, set this up as a proportion by putting this over 1, making this a fraction is equal to a fraction. Set this up as a proportion and solve that way. Okay. Or you can go ahead and rearrange it. It's up to you. All right, so let's put this in the TI Inspire and solve for X. So menu 3.1. Oh, that's not what I wanted to do. All right, so it's going to be X squared, so 8.02 times 10 to the negative fifth. Okay, and that's going to be squared over X. Okay, and that's going to be equal to the KB, which is 1.07 times 10 to the negative 8. Okay, let's solve for X. Oops, what did I do? Oh, I put times. I always do that. All right, it's not times. It's... Is it going to let me go back up? No. All right, so we're going to have to put it in all over again. All right, let's do it correctly this time. All right, 8.02 times 10 to the, times 10 to the negative fifth. Okay, and this is going to be squared over X. Okay, and this is going to be equal to, equal sign, 1.07 times 10 to the negative 8. Solve for X. All right, 6.01 times 10 to the negative 1. All right, so we have 6.01 times 10 to the negative 1 molarity, or 0.601. Okay. All right, that's our molarity. So Now let's calculate. I'm going to erase this right here because we have to do another calculation. Let's calculate the number of moles that we have with 6.4 grams. So 6.4 grams. Okay, we want to get rid of grams, convert it to moles. 1 mole is 33.04. Okay, and when I do that, I get 1.94 times 10 to the negative 1. I think. I have numbers written down over here to the side I'm just looking at. Let's go ahead and do that. (1.94) times 10 to the negative 1. So that's what that is. Yep. All right. So that's the number of moles divided by our molarity. Okay, so if you put in the answer here, this answer, divided by the molarity, 0.601, that should tell us how many liters. Okay, so we got 0.322 liters, 0.322 liters. Was it 322 or 332? 322 liters. Okay, and this question said how many milliliters? So it's 322. And I think it says, let's go back to here, 2 decimal places. So it should be 0.30. Let's go back and look at our calculator. 0.30 right there. 322.30. All right. Okay. So let's look at our next question. Calculate the pH of a solution containing a 0.2 molar NH3. All right, so this is going to be done the exact same way. The exact same way. You're just given different pieces of information. So I'm going to go ahead and help you set it up, but I'm not going to work this out fully. Okay, so we have NH3. We have to have an ice chart because this is a weak base. Okay, so what pieces of information are we given? The molarity, 0.02 molar. Zero, zero. It's going to go down by X, up by X, up by X. Okay, so this is going to be 0.02. Is that correct? 0.2. See, you got to be really, really careful that you write this down correctly. Double check yourself. Double check. 0.2. 0.2 minus X, X, and X. All right, and the other piece of information it gives you, that's it. It's saying what is the pH. Okay, so we're going to solve for X. We're going to solve for X here. In order to get this, you need the KB. So you're going to have to look up the KA and then calculate the KB. And then you can figure this out. Same way. Oops, that's not what I wanted. I want this. All right. It says hydrazine N3H4 is used in rocket fuel in producing polymer foams and in the production of airbags. The KB, okay, it gives you the KB 1.7 times 10 to the negative 6. Calculate the pH of the solution prepared by dissolving 13.5 grams in 269 milliliters. Okay, same way, same exact way. So I'm just gonna explain to you here how to set this up and what to do with all these numbers, and then you can do the ice chart and the calculations. So we have 13.5 grams in 269 milliliters. So what you're gonna do is you're gonna calculate a molarity. You're gonna convert this to moles. Okay, here's N3H4. Convert this to moles. Convert this to liters. Moles over liters is going to give you a molarity. So now you have your molarity for your ice chart. Here you have KB. So you're going to set this up. X squared over this molarity is equal to this KB. You're going to solve for X. X is going to be, this is a base, okay, because you're given KB. So you're going to get the constant, X is going to be your concentration of your OH. Okay, so then you can calculate a POH. Once you get your POH, you need pH. So you're going to subtract the POH from 14. It's going to give you the pH. Okay, once you subtract that from 14. Right? So if you need to go back and listen to this again and write down the steps, then you can do that. All right, so this one is tricky. So let's go ahead and look at it. Calculate the pH of a solution containing a fluorine concentration of a fluorine ion at a 0.6 molar. So you have a fluorine ion at 0.6 molar. Okay, so what you have to do on this one is you have to think about what can I combine. Now we're talking about acids and bases here, right? And what is the question asking for to calculate? pH, all right? So you're calculating pH. So pH, okay, when you write things down like this and just think it out, then it kind of helps you get to where you need to be. So in order to calculate pH, we need some concentration of a hydrogen ion. So if we take this and we add a hydrogen ion to it, then we're going to get HF. Okay, and HF is an acid, hydrofluoric acid. So if you think about what equation that you can make with hydrofluoric acid, you have HF yields H plus F, right? And so if you just take and rearrange this, you can get F. I guess you could use this same equation, HF, H plus F, right? So here's where you're going to make a mistake. And this is where this student made a mistake. Let me go back. Okay, so this student calculated the answer is 0.22. Okay, now let me show you how she got that and then explain about the very common mistake that was made. So here you have, let's go ahead and put this in 0.6 molarity here. Well, let's look at this. This is the, molar ratios, the law of molar ratios. If you have 1 mole of this 1 mole of this and 1 mole of this, and you know the molarity, then if this is 0.6, shouldn't this also be 0.6? Okay. And if that's a 0.6 molar, if that's the concentration, shouldn't I be able to take the negative log of this concentration and get the pH, which is the negative log of 0.6, base 10 of 0.6, okay, 0.22. So that's what the calculator tells you is 2.2 times 10 to the negative 1, or 0.22. Okay, so I'll slap a 0.22 in there. Got it wrong. Sorry. All right. So the reason that this is wrong is because, I'm trying to find this does not dissociate 100%. This is not a strong acid. This is a weak acid. So when we write the equation here, we're assuming that this dissociates 100%. If it dissociates 100%, then this will be 0.6. Okay, so you have to remember that this is a weak base. This is what we're in this section here, Kas and Kbs. These are all weak bases. Okay, and it doesn't work out that way with a weak base. So because this doesn't dissociate 100%, it only dissociates slightly. So that's where the Ka comes in. The Ka tells you to what extent this dissociates. So we're going to have to go to our Ka chart. We're going to have to find that equation, which is right here, okay? And this gives us the Ka of 3.5 times 10 to the negative 4. And I'm going to rearrange this equation so this can help us to solve this correctly the way we need to solve it. Okay, so we're starting off with this, okay? And this is going to go to HF plus OH because this is a hydrogen acceptor. So we have to think about this fluoride ion as being a Bronsted-Lowry base. If it's a Bronsted-Lowry base, it's going to accept a hydrogen when we mix it with water to become HF. And what's going to be left over here is the OH. When we pull a H off of water, you erase this now because that's not correct. This goes here. Now this is your standard everyday old ice chart. This is going to go down by X, up by X, up by X. Okay. And this is going to be 0.6 minus X, X, and X. All right, so we looked up the Ka for this. Erase all this. We looked up the Ka for this as being 3.5 times 10 to the negative 4. In the other direction, so we have to get the Kb for this. So 1.0 times 10 to the negative 14th over 3.5 times 10 to the negative 4 is going to give us our Kb. And our Kb comes out to be 2.86 times 10 to the negative 11. All right, so now it's the same old, x squared over 0.6. Okay, let's assume that we can drop this off, is equal to 2.86 times 10 to the negative 11th. All right, so we can solve for x now. And when we get our value for x, All right, so we have x squared over 0.6, our concentration. Let me make sure that's 0.6. Yeah, 0.6. Run our calculator. All right, so this is all equal to the KB, which is 2.86 times 10 to the negative 11th. Okay, solve for x. 4.14 times 10 to the negative 6. All right, that's the concentration of the OH. Now we're looking for pH, right? So with the concentration of OH, we can get POH. So take the negative log of this. And what was that again? 4.14. Oh, it's right here. Times 10 to the negative 6. All right, so that gives us a POH of 5.38, but we want pH. So we take 14 minus 5.38, and that gives us 8.62. All right, so is that the answer we should have got? 8.62. All right, so I hope this helps. If it does help you, slap that like button right across the face. Make sure that you subscribe and click the notification bell so when I do more videos like this that I don't put up on Canvas, where I'm working out actual problems from the quiz, you'll be notified of when those go up.